In 2.2 Part 2, we'll be talking specifically about piecewise functions. A piecewise function is a function that is defined by two or more equations over a specific domain, and it's called a piecewise function. So I think that as there's different pieces to it, there's at least two different pieces to the graph. So here's a real life example about a phone company. So let's say that it's $20 per month and that gets you 60 minutes. And if you want any additional time, that's going to cost 40 cents per minute. So we're assuming it's one of those phones where you have to pay by the minute. So you see we have two different equations here. And the C represents the cost, the T represents the time in minutes. So the first equation we can look at is this one here. It's the cost equals 20. So that represents this right here, $20 per month by 60 minutes. So it's a flat rate of $20 for anywhere from 0 to 60 minutes. And that's where we get this piece right here. So it could be exactly 0 and it could be exactly equal to 60. Or in between. Then our second equation is going to be right here. 20 plus 40 cents times T minus 60. So the 20 represents the first 60 minutes, but then if you go over the 60 minutes, it's 40 cents times whatever the minutes minus 60 is. So maybe you spent 80 minutes. So 80 minus 60 means you went 20 minutes over. So in this function, the T has to be greater than 60 because you only use it if the time goes over the allowed 60 minutes. Okay, so let's go ahead and use these and try to find some different costs. So find C of 40. So we're going to be using the first equation because our T is less than 60 minutes because we're wanting to put a 40 in place of the T. So we know that if it's between 0 and 60, it's just this flat rate of 20. So C of 40 is just going to be the $20. Now we'll find C of 80. So we're going to use the second equation, the 20 plus the 40 cents per minute that's over 60 since the T is more than 60. So for the time we're using 80. So we're going to replace this time with 80. That gives us 20 plus 40 cents. Then 80 minus 60 means we went 20 minutes over. So that, let me finish it, that would mean C of 80 is 20 plus 8, so $28. Okay, now we're going to be looking at a different piecewise function. We're going to try to make a graph for this. So in this one, our two equations are f of x equals 3 and f of x equals x minus 2. So one way to do this, if you know your slope-intercept form, we could work on that, but we're going to be using a table instead. So we're going to graph f in two different parts. So first we're going to look at this equation. So this, we only want x values that are less than or equal to -1. So they chose -1, -2, and -3. So f of x, we're just going to replace our x with the number we chose for x. So f of -1, now there's nothing else that we're putting with the 3. These are all just going to equal 3. So our coordinate is -1, 3. So f of -2 is still just 3. So that coordinate is -2, 3. And f of -3 is still 3, so -3, 3. So our next one is x is greater than -1. Now we're still going to use -1 and we're just going to use an open circle to show that that's where the graph is going to start. And then, because it could be anything from -1 on. So it could be negative 0.99999. It just can't be exactly -1. It has to be bigger than that. So you still want to use the -1, and we're going to replace the x's with -1s. So f of -1 is -1 minus 2, which is -3. So our coordinates -1, -3. So f of 0 would be 0 minus 2, which gives us -2. So our coordinate is 0, -2. And then f of 1 would be 1 minus 2, which is -1. So 1 comma -1 would be our next coordinate. Then we're going to take these sets of coordinates and graph them on the next slide. So here are two different tables. So here, this first one was when x was less than or equal to -1, so that was this equation. So you can notice it's just a horizontal line. So I graph -1, 3, then I graph -2, 3, then I graph -3, 3. And it says less than or equal to -1, so that's why it keeps going forever and ever in the negative direction. So you notice it starts at -1, and it can equal, because it's less than or equal to -1, so it's a closed dot, and then it just keeps going forever in the negative direction. Then our next one is over here. Our f of x is x minus 2, and our coordinates were -1, -3, but we said it had to be greater than -1, so it's where the graph starts, but it can't include the -1. And then we have 0, -2, and then 1, -1. And then this one is anything greater than -1, so it keeps going forever and ever in the positive direction. So you can see from the graph that it's two different pieces to the graph. So that's how I remember piecewise, you're usually going to have two or more different pieces to the graph that probably aren't going to be connected to each other. Sometimes they are, but this one is not. Okay, now we're going to finish with the definition of the difference quotient of a function. So this is the expression we're going to be using, and h cannot equal 0. It's called the difference quotient of the function f. So we're going to be looking at some examples on the next few slides. So if f of x equals 2x squared minus x plus 3, find and simplify the expression. So we're going to complete this in pieces. So we're first going to look at the f of x plus h part. So again, that means we're going to replace any x with x plus h. So our original was 2x squared minus x plus 3. So wherever I see an x, I'm going to put the x plus h. So here I'm going to put x plus h, but then I need to square it, minus, put another x plus h, then this plus 3 just gets tagged on at the end. So now we need to be careful here, x plus h squared. So let me do that off to the side. X plus h squared means x plus h times itself. So I'm going to use FOIL. So if I simplify that, I have x squared, and I have two xh's and an h squared. So that is going to go in place of this right here. Now this negative needs to be distributed to both of these, so it'd be minus x minus h plus 3. And then I need to distribute my 2 to everything in here. So that's 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Okay, and let's look at that if there's anything we can do. It doesn't look like anything can be combined in that one. So that is our partial answer for the first part, f of x plus h. We're going to use this in place of this piece on the next slide. Okay, so here's that piece that we just said. So I'm going to recopy what I had. I had 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Then minus f of x. So that's just our original. So I'm going to minus that whole original equation. And it's going to be all over the letter h on the bottom. So I'm going to put an h under this whole thing. Okay, so let me go ahead and distribute this negative piece here. So I'm going to change everything into its opposite. So opposite, opposite, opposite. And now let's see if anything can go together. So my 2x squared and my 2x squared actually cancel each other out. And I only have one thing that has an x and an h, so let me bring that down. Then I only have one thing that has an h squared. Then I have a negative x and a positive x, so those will cancel out. Then I have a negative h on the top, and I have a positive 3 and a negative 3. Those will cancel out. So I'm left with this. And you actually can simplify this. So if I look at all 4 pieces, there is an h. So on the top, I can pull an h out of everything. That leaves me with this. H pulled out of a minus h is at just negative 1 now. And finally, the h's, one's on the top, one's on the bottom. So my final answer is right here. That is all I have left. So my difference quotient all that work came out to 4x plus 2h minus 1. So it's really not too bad. It's just a lot of plugging in and replacing and doing distributive property, and then things should start canceling out for you. Let's go ahead and try one more of those. So here's our difference quotient. And I forgot to mention, this is for looking at average rate of change. This is a ratio that's going to play an important role in understanding the rate at which functions change that we'll talk about in future lessons. So f of x plus h, that means we're going to replace all the x's with x plus h. So I have negative 2 x plus h squared plus x plus h plus 5. Now we said in the last lesson, or the last slide, that this whole thing gives you x squared plus 2xh plus h squared when you use FOIL, and then plus x plus h plus 5. Now I can distribute. Be negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. And there's nothing that can be combined, so this is our entire thing for the f is x plus h portion right here. So we're going to take that and transfer it to the next part of the equation. So here's that piece. So I will rewrite what that was. It was negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. And now I'm going to subtract the original f of x right here. Make sure you're subtracting the entire quantity. And that's going to be all over h. So I will go ahead and just change these all to their opposites and then see what cancels. So these will cancel. My x's will cancel. And my 5's will cancel. So I'm left with negative 4xh minus 2h squared plus h all over h after everything canceled. So I can factor out that h from the top. Is with negative 4x minus 2h plus 1 all over h. Finally, the h's cancel. So my difference quotient, f of x plus h minus f of x over h equals, this is all I have left, negative 4x minus 2h plus 1, and the h cannot equal 0. I forgot to say that on the last one, so just make sure you remember that h cannot equal 0 in these. And that is the end of this lesson.